Hey guys, welcome to Heart Academy for January 15th, 2019, and this is for my Earth Science class at the Goodwill Excel Center. All right, so I'm thinking like I should totally stop actually saying the dates on these things because I'm going to be reusing them every term. And for us, every term is like every 8 weeks. I'm like, yeah, why am I like keep putting dates on it? Well. So, yeah, but you know me, I'm not going to stop and re-record. So anyway, what I'm reviewing today is the homework that I've given you. And so I just kind of gave it to you in class today, so I want to make sure that everyone understands what they're doing with it, okay? And be aware there's a new late work or not here work policy that I'll be reviewing in class. Make sure everybody's on the same page. Basically, if you're not here in order to get the work, you got to have an excused absence from work note from your coach. And I'll talk more about that during the rest of this week and next week, so we're all on the same page. So basically, simply because that it's posted in my Google Classroom, it may or may not be accepted for credit depending if your absence was excused. So I'll talk more about that tomorrow. And again, I'll keep continuing to talk about it next week, and I'll also post it in our Google Classroom. So let's move on. I talk pretty fast, especially when I'm drinking Red Bull. All right. So here, we're talking about Earth structure. So I will read and point out to you where you can find answers at. Now, this part right here is not necessary for you to do, but some people like to do it. It's the part about, what do you think before reading? And it says, what do you think? Read the two statements below and decide whether you agree or disagree with them. Place an A in the before column if you agree with the statement, or D if you disagree. If you've read this lesson, reread the statements to see if you had a change of mind. And so the first one, 3, Earth's interior is made up of distinct layers. Do you agree or disagree? So you can put an A here or a D here. And then also for number 4, scientists discovered the Earth's outer core is liquid by drilling deep wells. Now again, you can put A if you agree or D if you disagree. And then after you do your reading, you go back to see if your answers have changed. But again, like I said, you don't have to worry about this part too much, okay? So going from here, read to learn. Clues to Earth's interior. I'm going to go ahead and read and then point out the questions as we go along, the questions that should be answered in your packet, which is this right here. All right. So it says clues to Earth's interior. You cannot see very far inside Earth. The deepest mines and wells do not go much deeper than Earth's surface. How do scientists learn about Earth's interior? They use many methods to discover what is underneath the surface. Next paragraph. What's below Earth's surface? Scientists use deep mines as well to get clues about what is below Earth's surface. The deepest mine ever made is more than 3 kilometers deep. People can use this mine to explore the geosphere. The deepest well is more than 12 kilometers deep. People cannot go down into the well. Instead, they bring samples to the surface. They also send tools down to make observations. Okay, this prediction question right here is for you to answer after reading this one. Temperature and pressure increase with depth. It is hot in deep mines and wells. This is a clue that it is hot inside Earth. It gets hotter as you go deeper. The temperature is about 53 degrees Celsius or 127 degrees Fahrenheit near the bottom of the deepest mine, and about 190 degrees Celsius or 374 degrees Fahrenheit near the bottom of the deepest well. There is no way to measure the temperature of Earth's center. Scientists estimate that it's about 6,000 degrees Celsius or 10,832 degrees Fahrenheit. Prediction question. What kind of things might scientists measure in a mine or a well? So what type of things would scientists measure in a mine or a well? Think of things that would be in a mine or well. For instance, in a mine, you might find some rocks. So either the soil. And wells, you get a water sample, etc. type of things. Or you can think of some other things on your own as well. Okay. Now, moving on to this next question. Erase this. I got to erase as I go. If not, the answer's stay. I don't know if anybody's noticed that. All right. Well, you got that one there, so now I'm going to take it out. There it goes. Whoops. Okay, so moving down to the next page. Now, also, too, this is a good clue for when you have questions that have the check mark, right? The check mark question, your answer should be near where the check mark is in a paragraph. So let's find out if that's true. Pressure. Just as temperature increases, pressure increases towards the center of the Earth. The weight of the rocks on the surface pushes on the rocks below. This pressure makes the rocks below more dense than the rocks on the surface. So the question here, how does pressure change toward the center of the Earth? So that's what we have. We just read that. So it says the pressure makes the rocks blow more dense than the rocks on the surface. So how does pressure change towards the center of the Earth? Just as temperature increases, pressure increases towards the center of the Earth. This is a good sentence that I would put over here. Now I'm circling these answers, but I expect yours to be typed in. And so I know you're not really listening to this if you're just watching what I'm doing and not actually writing the sentence in. Okay? And so if you're just writing or copying what I'm doing on my page, I know you're not really listening to what I'm saying. And so you're just kind of watching what my movements are. And if you have this on your paper like this, I'm going to count it wrong. You should be writing the sentence in. Okay? All right, moving on. So now let's go down to deep wells. Okay. The high temperature and pressure inside Earth makes it impossible to dig deep wells. Therefore, scientists have sampled only a small part of the geosphere. How can scientists learn about what is below the deepest wells? Using earthquake waves. That's how they learn. Scientists use indirect methods to learn about what is inside Earth. So indirect means kind of like, another way around it, but not exactly doing it. So it's indirectly. Most of their data comes from studying earthquake waves. How can scientists learn about what is inside Earth by using earthquakes? Earthquakes release energy in the form of 3 types of waves. These waves move through Earth. They move in different ways through the different materials. They speed up in more dense materials and slow down in less dense materials. Some waves change direction when they reach certain materials. Others cannot travel through some materials. By studying how the waves move, scientists can learn about the density and structure of materials in the Earth. All right. So if you're watching this video and you're actually listening to me, I got some tricks that I do sometimes that get points for students. If you are watching me and you're actually listening to what I'm doing, right here, I want you to put a heart. That's right, draw a heart right here. And what this tells me is that you're actually listening to the video, and I will give you 10 points if you have a heart drawn right here on this page. Now I'm going to move on. Let's see how many people actually draw that heart. Right here, this page, 10 points. All right, Earth's layers. Here we go. Going on to the next part, Earth's layers. As you learn, differences in density result in the materials within Earth's forming layers. Each layer of Earth is made up of different materials. The densest materials are at Earth's center, crust. Earth's crust is a brittle, rocky outer layer. The crust is much thinner than the other layers of the geosphere. You might think of the crust as the shell on a hard-cooked egg. The crust is not only the thinnest layer, but is also the least dense layer of the geosphere. The crust is made up of mostly of elements of low mass, such as silicon and oxygen. Rocks on the crust are under oceans and on land. The crust under oceans is called oceanic crust. It is formed of dense rocks and contains iron and magnesium. We know that now, don't we? We remember reading that last week. The crust on land is called continental crust. Continental crust is about 4 times thicker than oceanic crust. Continental crust is thickest under tall mountains. Continental crust is less dense than oceanic crust. Now we have information to answer the question here. Contrast, which means compare the two differences. Compare the thickness and density of oceanic crust and continental crust. So that information you have should be right up here. Let's see. Okay, oceanic crust. Oceanic crust formed of dense rocks that contains iron and magnesium, and then the crust on the land is called continental crust. Crust is 4 times thicker for continental crust, and I'll change the color here. For continental crust is about 4 times thicker than oceanic crust. Okay, so all this information, right, you can put right here for your answer. All right, moving on. All right, so now we talk about the mantle, okay? So for the mantle, Earth's mantle is a layer just below the crust. The mantle is a thick middle layer in the solid part of Earth. The mantle contains more iron and magnesium than the oceanic crust does. This makes the mantle more dense than either the continental crust or the oceanic crust. The mantle is made up of rock, just like the crust. Scientists group the mantle into 4 layers. In each layer, the rocks react differently when forces push or pull on them. And we know what those forces are. Convectional currents do that. Uppermost mantle. Now this is new, okay? So we have not actually discussed the uppermost mantle, but we have discussed the lithosphere and asthenosphere. Okay, so for the uppermost mantle, The uppermost layer of the mantle is made of hard rock. These brittle, rigid rocks are similar to the rocks in the crust. For this reason, scientists group together the crust and the uppermost mantle into a rigid or hard layer called the lithosphere. So the lithosphere is where the upper mantle is where the lithosphere is, or vice versa. Lithosphere is in the upper mantle part. Okay, that would make a good test question. Hint, hint. Put a star right here if you're listening to me. All right. Put a star right here if you're listening to me, because that would make a good test question. All right. Asthenosphere. The asthenosphere, the rocks below the lithosphere are so hot that tiny bits melt. When this happens, the rocks are no longer brittle. They begin to flow. When a material such as rocks flows, scientists use the word plastic. The plastic layer within the mantle is called the asthenosphere. Boom, right here. How do the rocks in lithosphere and the asthenosphere differ? Well, there we go. And for this reason, scientists group together the crust. Let's see. The uppermost layer of the mantle, these are brittle, rigid rocks, are similar to the rocks in the crust. So the uppermost layer, I would say the uppermost layer of the mantle, hard layer called lithosphere. And then for the asthenosphere, it's not so hard. So I would put, like, when a material, let's see, the rocks below the lithosphere are so hot, they're brittle. So now you have these in the lithosphere, the hard, and then the asthenosphere, the brittle. So however you can word that would go right here. Okay, and now moving on. Here we go. Upper mantle and the lower mantle. The rocks below the asthenosphere shown below is solid, even though it is hotter than the rocks in the asthenosphere. How can it be solid when the cooler rock in the asthenosphere is plastic? The pressure below the asthenosphere is so hot that melting does not occur. High pressure squeezes the hot rocks into a solid. This solid rock of the upper mantle and lower mantle form the largest layer of the earth, which is known as the mantle. Okay, so number 5, what material makes up the largest layer of the earth? What material makes up the largest layer of the earth? Let's find out. So the material that makes up the largest layer of the earth would be the asthenosphere and the upper mantle. The solid rock of the upper mantle and lower mantle. There we go. We can put this here. And that would be for the answer for that one. And moving right along, visual check. Name the layers of the mantle shown in the figure. So here, you can use this to fill in this area, the layers of the mantle. So remember, the layer of the mantle, we're talking about here. Okay? And all right, now we get to talk about the core. Okay, so we're almost there. So talking about the core now. The dense metallic center of Earth is the core. And it says, imagine again that Earth is a hard cooked egg. The yolk of the egg would be Earth's core. Earth's crust and mantle are made of rock. Why do you think the core is made of metal? Remember, the early Earth was much hotter than it is now. Earth's materials flowed just like they do in the asthenosphere today. As you learned earlier in this chapter, or earlier last term, whenever you were last in school, early Earth was soft enough for gravity to pull on the densest material to the center. That dense material is metal. The core is mostly iron with small amounts of nickel and other elements. It has a liquid outer core and a solid inner core. Ding! So we have nickel here. By the way, science words. And then now, name what are the interior layers of the Earth. All right, so name what's on the, name what are the interior layers of the Earth. The dense material is metal. Whoops. Metal. The core is mostly iron with some amount of nickel and other elements. What are the interior layers of Earth? We have this information right here. You choose any of that to go right here. Now, talking about the outer core. Here we go. Outer core. You learned that pressure in the lower mantle is great enough to keep the rock in a solid state even though it is very hot. How then could the outer core, where the pressure is very high, be liquid? The answer is that the mantle and the core are made of different materials. These materials melt at different temperatures. Just as in the asthenosphere, the effect of temperature outweigh the effects of pressure in the outer core. Scientists learned that the outer core is liquid by studying what happens to earthquake waves when they enter the outer core. Ding! What evidence shows that Earth's outer core is liquid? We have this information right here. What evidence is from what scientists have studied. Okay, and we can also put this information to you. The outer core and mantle are made of different materials which melt at different temperatures. Any one of those would be great for an answer. All right, so next we're talking about inner core. Should be a question that goes along with that. Ooh, and it does. All right, so inner core. Earth's inner core, shown in the figure below, is a dense ball of solid iron crystals. Here we go. This temperature at the center of the Earth is about 6,000 degrees Celsius. That's very hot. Because the pressure is so high, the iron is in solid state. The liquid outer core is not tightly attached to the solid inner core. Therefore, the two layers of the core can spin at different speeds. The inner core spins a little faster than the rest of the Earth does. So remember, we were talking about last week how the inner core spins faster than Earth rotates. So, question number 9, how do the arrows in the figure show that the inner core spins faster than the outer core? Well, that's because the inner core, the arrow is longer, okay? So you can put that here, like the arrow is longer, and so that means it's spinning faster. You can write that as part of the answer. I'm good with that. Or however else you want to explain that picture. All right, last part is Earth's core and geomagnetism. Ooh, this is good. Have you ever used a compass? No, not really, because I'm so directionally impaired I can't use a compass. All right? I forgot I had some cheese and crackers. I'm hungry. Is the ice cold? I'm also listening to music in my earphone. Oop, my bad. I don't know what to do that. I don't want to plan. I'm trying to do that. There we go. Okay, sorry. My bad. Alright. Going back to the compass, which I never use because I can't read it. The needle on the compass points north. The metallic compass needle lines up with a force field around the Earth. This force field, which is shown below, is caused by Earth's core. What's that force field we're all familiar with? The magnetic field. As you learn, Earth's inner core spins faster than the outer core does. This produces streams of flowing molten iron in the outer core. The movement of these molten materials produces Earth's magnetic field. Okay? So number 10, what does the arrows on the picture represent? Number 10, I say the arrows in the picture represents the force field. Okay? So the force field or the magnetic field, so I would say it's this, or even if you put force field, I'm going to count it right for this one right here. Okay? And then, all right. As you learn Earth's inner core, wait, did we just read that? The movement of the materials produce Earth's magnetic field. Okay, so magnetic field here, or force field, same. And now going down to this part. Force field, I think they kind of want to separate because it's the same thing if you ask me. Force field and magnetic field for down here. Hold on, let me find out and read some more. Okay, so for centuries people have used compasses on Earth's magnetic field to navigate, but the magnetic field does not stay the same. Over geologic time, the magnetic field's strength and direction changed. The poles have even reversed direction several times in Earth's history. Yeah, I just learned something new. Magnetosphere. Earth's magnetic field protects Earth from charged particles and the flow from the sun. The magnetic field pushes away some charged particles and traps others. The outer part of the magnetic field that affects the charged particles is called the Magnetosphere. The flow of these particles produces the shape of the magnetic sphere. Okay, so what I'm sensing is that you should put the force field. These arrows represent the force field, technically, but if you don't change your answer, I'm still okay with that. And this one is talking about the magnetic field going down here, okay? So the difference between the two, but yet they're still kind of one and the same. We'll talk more about it in class. And then for this last question right over here, compare Like Earth's magnetic field, a magnet in your hand pushes away some things and draws other things towards it. Name an object that a magnet would draw into its field. Name an object that would repel the magnet. I have no idea. I don't care if you do this question or not. It's not going to be on the test. All right, my friends, that will conclude for the day. And I'll see everybody in the morning. Peace out.